Hello everyone, we are solving problems on the superposition theorem. In that, next question is, for the following network, find the current I through the link CD by using superposition theorem. The resistance of link is 0. This is the given circuit. The examiner is asking the current flowing through link, okay, this link, and the resistance of this link is given as, that is short circuit, 0. 0 ohms means short circuit. So by superposition theorem, whenever one source is acting alone, other sources must be replaced by, if it is voltage source, with short circuit, if it is current source, with open circuit. Now consider 5 volt source only. Case 1, 5 volt source acting alone, then circuit becomes like this. Here the current flowing through this link, okay, here it is CD. So other sources are replaced with short circuit because other two sources are voltage sources, so we are replacing with short circuit. If you observe here, this is short circuit. Current is coming from this 5 volt source to here. Whenever reaches to this node, here there is a short circuit path. So current is always chooses short circuit path only. So current never go in this path. So the circuit becomes like this. Now by Ohm's law, what is I1? I1 is equal to 5 by 1 is equal to 5 amps. Next one, case 2. If 20 volt source acting alone, 5 volt source is replaced with short circuit and 10 volt source is replaced with short circuit. Then circuit becomes like this. The response due to 20 volt source, let it be I2. Okay, here also same. So this 1 ohm is connected across short circuit. So current is always chooses short circuit path. So this 1 ohm is neglected. Now what is current I? I is equal to, let it be I2. Okay, I2 is equal to, all these three resistors are connected in series. So equivalent is summation of all resistors. The voltage is 20 volts. V by R equivalent. So what you are getting, I2 is equal to, this is 20 by 15, 4 by 3 amps. Next, case 3. If 10 volt source acting alone, this 20 volt source and 5 volt source are replaced with short circuit. Then circuit becomes like this. Here also this 1 ohm is connected across short circuit. So current is always flowing through the short circuit only. So the 1 ohm is neglected. So this is closed loop. So the current flowing through this closed loop is I3. Okay, the response due to 10 volt source acting alone is I3. So I3 is equal to, all these three resistors are connected in series. Equivalent is 4 plus 8 plus 3. So what is the voltage? 10 volts. V by R equivalent. So you will get 10 by 15. So I3 is 2 by 3 amps. By superposition theorem, what is ICD? So ICD is equal to I1 plus I2 plus I3. That is, so I1 is, we got 5 amps, 4 by 3 plus 2 by 3. So what is ICD? ICD is 7 amps. Next question is, a network consists of several resistors, one of which is designated as R, and there are two dependent sources. The power dissipated in the resistor R is P1 due to first source acting alone and P2 due to second source acting alone. Determine the power P of resistor R when both sources are acting simultaneously. Okay, in the question what is given? So there is a one resistor in the network and there are two sources. So let it be V1 and source V1 and V2. Okay, there is a resistance R. If V1 is acting alone, the power is P1. If V2 is acting alone, power is P2. If two sources are acting simultaneously, what is the power P in the resistor? Okay, so according to superposition theorem, what is the voltage across resistor? V is equal to V1 plus V2. I is equal to I1 plus I2. But P is not equal to P1 plus P2. Why? Because, so what is P formula? P is equal to I square R. Okay, so total current flowing through resistor is I, not I1 plus I, sorry, not I1 or not only I2. So what is I1 plus I2? I1 plus, sorry, what is I1 plus I2 into R? You will get I1 square R plus I2 square R plus 2I1 I2 R. This is P, power dissipated across resistor. Okay, for suppose if single source acting alone, so what is P1? P1 is equal to I1 square R. What is P2? I2 square R. Now what is P? If you take P is equal to P1 plus P2, what you are getting? I1 square R plus I2 square R. Okay, so these two are not equal. P is not equal to P1 plus P2. Okay, so formula is this one. Now from these formulas, find the power dissipated in the resistor R. From this, what is I1? I1 is equal to plus or minus square root of P1 by R. And from this, what is I2? I2 is equal to plus or minus square root of P2 by R. Okay, so what is the total current? The response in a resistor due to both sources acting simultaneously is I1 plus I2, that is equal to plus or minus root P1 by R and plus or minus root P2 by R. Now what is the power dissipated across resistor? PR is equal to I square R. So what is I? I is equal to plus or minus root P1 by R plus or minus root P2 by R whole square into R. So if you take common here, R here, this is root R and this is root R. 1 by root R. Root R whole square means 1 by R. This R and this R gets cancelled. Then you will get PR is equal to plus or minus root P1 and plus or minus root P2 whole square. Very, very important formula. Please remember this. Okay. So the formula for if two sources acting simultaneously, the power across any resistor, that is the power dissipated by any resistor, any element is square root of plus or minus square root of P1 plus or minus square root of P2 whole square. If three sources are there, then the power is plus or minus root P1 plus or minus root P2 plus or minus root P3 whole square. Next question is, for the network shown in the figure, the power P in the resistor is calculated when each source is acting alone and the values are 18 watts, 50 watts and 98 watts respectively. Find the P max and P minimum. This is the given network. So when each source acting alone, the power values are 18 watts, 50 watts and 98 watts. Okay, this is belongs to E1, this is belongs to E2, this is belongs to E3. So by using superposition theorem, what is the power? Power is equal to plus or minus square root of P1 plus or minus square root of P2 plus or minus square root of P3 whole square. Okay, now I want to find out P maximum. P maximum means consider all positives. Okay, if you consider all positives, then you will get P maximum. So substitute P1 is 18 plus P2 is 50 plus P3 is 98 whole square. Okay, so what is the formula? P1 plus P2 plus P3 under root each one whole square. Now what is P max 1? P max 1 is, take common 2 here and 2. If you take common 2 here, so that is root 2 whole square. Root 2 whole square means, let it be root 2 whole square into, this is root 9 plus root 25 plus root 49 whole square. So P maximum is root 2 whole square means 2 This is 3 plus 5 plus 7 whole square. P max is equal to, if you solve this, you will get 450 watts. Now, what is the P minimum? P minimum is equal to, so how to get P minimum? Either add 2 powers and subtract other power, or add 2 powers and subtract another power. Okay, so from this, if you add these two and subtract this one, that means 7 plus 5, 12. 12 minus 3, you will get 9 whole square. Or you can add these two. 3 plus 5 minus 7. How much you are getting? 1 whole square. Or add these two and subtract this one. 10 this 3 plus 7, 10 minus 5, 5 whole square. So from all these, this one is minimum value. So we have 3 cases here. What is that cases? Root P1 plus root P2 minus root P3 whole square, or root P1 minus root P2 plus root P3 whole square, or minus root P1 plus root P2 plus root P3 whole square. Okay, these are the possibilities to get minimum power. So from this, which one is correct? So add these two and subtract this one. Okay, so we choose this one. So what we are getting? This is root 2 whole square into root 9 plus root 25 minus root 49 whole square. So what is the P minimum? 2 watts. Okay, with this, superposition theorem is completed. In the next video, we will discuss Thevenin's theorem. Thank you for watching.